I know as much as you want, but
Man. Can it be alcohol?
you can if you want.
Yeah.
All right, so the one thing that you have to understand, a sequence that's monotonic, that means the term are, either keep on going up or keep on going down. It's, just so definition of monotonic. Mono means one, and tonic is actually directions. So it's one direction, it's gonna go up or going down. It doesn't have a fluctuation. So those are the things that you have to understand. So how do you prove it's monotonic? It's kind of important skills that you guys want to think about. So first of all, a to the n equal to 3 plus negative 1 to the n. Is this monotonic?
No. Well, yeah. Well, no, because then if it's a negative or subtraction from 3, and then 4, 2, 4.
Oh, I'm sorry, my bad.
No, it's not. It's not.
Okay, so what is monotonic is either A1 is less equal to A2, less equal to A3, less equal to A4, and dot 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 to the A to the N. Or A1 is greater than A2, is greater than A3, is greater than A4. So it could be any of those things. Okay, so is this monotonic? Is 3 plus negative 1. Why is that?
Because it'll only ever be 4 or 2. It'll be going between.
So this is oscillation, right?
Yeah.
Now you understand what I was saying. Okay.
So if it's an oscillation, it's not monotonic. Very, very important. It's Bn equal to 2n over n plus 1. Is that monotonic?
Yeah. No. Wait. No. Yeah. 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 It is. Because 2n increases faster than apple pie. Yeah. So it would just be generally increasing. Yeah. Whenever.
But how, even you decided yes or no, do you know how to decide to how to prove it, right? So the best way to prove it is to compare. Okay, sequence and series is very emphasized on comparing something. Okay, comparing something. You need to learn how to compare because this is going to be a one small step later. Okay, so sometimes you have to figure out, are they strictly increasing or are they strictly decreasing? So then you have to figure out what happened. So let's just say if I want to compare this term, and this is a generalized, this is an arbitrary n number and can be any values. So how do you compare to the next term?
Two numbers.
Plug in the comparison of 2 to the n plus 1, the next term of n plus 1 plus 1.
2n plus 2. Oh wait, yeah, no.
Am I doing okay? So let's just say if I want to compare this, which term do you think is going to be, are they going to be larger or are they going to be smaller? So what do you think? Okay, if you really have struggling, let's look at the graph. Okay, so it'd be 2x all over 1 plus x. And we are talking about n is a positive value, so n can only be positive from here, so it starts from 1. They keep on going up. It seems like strictly increasing, right? But you're gonna say, hey, how about the other side of the graph? I don't really care about the other side of the graph because n is always positive. It's going to increasing. So therefore, they are strictly increasing. You're gonna say, no, 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 this has well, it's still increasing on this side, but it's gonna be an asymptote. But you don't worry about that side. You start worrying when this value right here. So start at 1, right? Usually n is equal to 1, and moving on, are they increasing or decreasing? So you're gonna compare. So we're gonna say, usually this is gonna be greater. So let's just say if it's always greater, it's gonna be a true statement or not. How do you prove whether it's true statement or not? Well, we can simplify. We can say 2n over n plus 1 is less than 2 times n plus 1 over n plus 2.
Yeah, what is that? That's a new.
Can I do cross multiply?
I guess. If you want
Long as we create a true statement, that's always going to be true. So n plus 1 here. So if I distribute, what am I going to get? 2n squared plus what? 4n, good. And I here is going to be 2 times n squared plus 2n plus 1, I believe. And guess what? 2n squared plus 4n is less than 2n squared plus 4n plus 2. So can I cross this out? So 0 is less than 2. It's a true statement.
I mean, yeah. What if 0 doesn't want to be less than 2 anymore? Wow. It is 2023.
Yeah, that's why you, Samuel. That's why you have to change your side. Yeah, I think a lot of time people don't get why they have to change size. All right, so so if this is true, that means the function is keep on going up. Because we establish this is true, and this not only is true, it's always true. If it's always true, that means the function is keep on going up slowly. Not like really fast, but it's very, very slow. So that's how do you prove what a function is monotonic. So you want to think about function of monotonic because later on you have to deal with something like integral test. What?
Delayed your sneeze. You got like half of you have like 1.5 sneezes. Oh Jesus. I didn't even do it.
So here's the thinking about this. Here's the thinking about this. How about this sequence of n squared over 2n minus 1? Okay, if something like this, just a normal algebra expression, it's really easy to establish a proof. You can plug in n plus 1 and compare. Now, in this case, it's going to be slightly harder. So you kind of have to think about what happened between first term and second term and third term. If you can disprove that's true, then this automatically, if you disprove it, then it's automatically not a monotonic. So if I were to plug in, let's just say, if what happened if I plug in 1?
And over
1 over 1? What happened if you plug in 2?
4.
4 over 3. What happened if you plug in c to the 3?
You would get 9 over 8. 7.
9 over what? Okay, so here's my question. That's like gonna be a hard question for you guys. It's 9 over 7. It's 9 over 7 greater than 4 over 3. Oh my god.
No, it's not. It's 27. In what world is it? Oh wait.
This is actually a really hard comparison.
It's 0.
It's 28 over 21. And then
Remember, 1
27
over
over
7
21.
is 0.14.
Okay, for you guys don't know how to do simple math, I had to teach this at a 3rd grade level. You had to multiply this by 7 over 7, 3 over 3. This is the 28 over 21, and this is what? Which is this size greater. So this is a kind of crazy. I think like I actually had to teach my son 6th grade about this. Oh no, he's at 3rd grade. So he tried to compare a fraction because I asked him to do 5th grade stuff all the time. So I usually ask him to do 2nd grade level. And I said, can you do it? And he's like, I don't know how to do it. So I had to teach him like this. So yes, you can compare. So if you can disprove anything that's monotonic, especially first 3 term, if you said, okay, this is not true, this one is actually the biggest one here, so that is not monotonic. Okay, so the key thing is oscillation is not monotonic. If you can plug in the first 3 term and you can see that you went up and went back down, that's automatically not monotonic. But if you can prove in, like say something that's simple algebra, like say 2n over 1 plus n, that's easy to prove. You can actually plug in the n plus 1 and then see if that's true, right? If that's true, then that's a monotonic. So you got to be able to do that. I want to go back to talk about something I did forget to talk about is this. It's the limits for sequence a to the n if limit n approach infinity of absolute value n an is equal to 0, the limits n approach infinity of a to the n is also equal to 0. Does that make sense or no?
Yeah. Wait, negative is the absolute value bigger or equal to 0?
What?
It's just because the absolute value is 0.
No, if you make it anything absolute value, if you absolute value something, and if that go into 0, and then the other side, the actual sequence, all go into the 0.
Negative 1. Never be negative.
Good. That's another way to think about it. Negative 1 over infinity, or negative 1 over infinity, or 1 over negative infinity, or 1 over positive infinity, they all zeros. So that is the case. So how do we prove that if we have, say, if a to the n is equal to negative 1 to the n over n? So
Oh, that makes sense.
Wait, no, it's not. Either way, it's gonna put 0. That's a crazy denominator right there.
So, how do we know if this is true? All you gotta do is put an absolute value around it, right? So let's say absolute value a to the n. That's equal to absolute value of -1 over n to the n, like this. But if I do absolute value of this sequence, will eventually lead to what? The same thing is 1 over n. It's no different because I don't have a sign change. Now, if limit n approach infinity and 1 over n is equal to 0, therefore this is also going to 0. So therefore it's 0. That's it. So absolute value basically take a negative sign away. That's a very, very important skill later on. So we're just trying to build all the basic skill for you to do it later.
I wish you the best.